Hello guys, welcome to my YouTube channel. On this video, we're going to learn how to integrate a function using method of substitution. So we're going to handle this question, that is the integral of secx over tan squared x dx. But first, before we start with this tutorial, I want to thank everyone for your help with my channel. That is helping me attain 200 subscribers. But please, if you've not subscribed to my channel, please check the subscription button and subscribe. Thank you. So now with this, when they give a question like this and you want to use the method of substitution, what you need to do is, now you need to make sure that this is reduced to its simplest form. That when we talk about it, the simplest form is, as you can see, sec s can be 1 over cos s, and tan squared x can be, that is sin squared x over cos squared x. So you can reduce this before you start with method of what? Substitution. Let's start. So this is the question given to us. Now we attain this because, as you can see, sec s is 1 over cos s times this is 1 over tan squared x. So when you take the reciprocal, that you reciprocate this, you're going to get cos squared x over sin squared x dx, because it will be 1 over tan squared x, which is the same as 1 over sin squared x over cos squared x. And when you do that, you're going to get this. Now when you get this in a simpler form, we try to make it simpler before we apply the substitution rule. So what you need to do is, as you can see, this can take this cos x. We'll take one of this cos x here. So here will be remaining with only cos x. So when you do that correctly, you're going to get the integral of what? Cos x over sin squared x dx. So as you can see, this has been this whole question, it has been reduced to this question. So now we've reduced it to the simplest form. Now we can apply the substitution rule. That is, we are going to make u be equal to 1, the s with the complex function. So if you can see, sin squared s is the complex function. So you're going to by using substitution method of integration, you're going to let u be equal to sin x. So we are going to represent u to be sin x. So if you make u be equal to sin x, when you differentiate sin x, you're going to get cos x here. So you're going to get cos x. So the u over the x will be what? Cos x. Now what you need to do is now try to make the s the subject so that you can substitute it here. So we are trying making the s the subject, and when you do it correctly, you're going to get du over cos x. So now after getting this, you're going to place this du over cos s into this equation. So now you get integral of cos x over u squared dx. Now the u squared is from here. As you can see, we made u be equal to what? Sin x. So when sin x squared, it will be what? U squared. After doing this, what you need to do is, you're going to replace the dx with du over cos x. So when you do that correctly, this cos x will take care of this cos x, leaving 1 over u squared du. So this is what you're going to integrate, and with this you can rewrite this as, that is the integral of u exponent negative 2 du. And when we do the integration of this, you're going to add 1 to that over the total we had there. So negative u exponent negative 2 plus 1, you get negative 1 over negative 1 plus c. For us to rewrite it correctly, you can get negative u exponent negative 1 plus c. Now we know that our u is sin x, so you're going to place in sin x, which will give you negative 1 over sin x. As you know, u exponent negative 1 can be written as 1 over u, which will give you 1 over sin x. But the negative sign is affected, so negative what? 1 over sin x plus c. As you know, 1 over sin x will give you cosec x. So your final answer will be negative cosec x plus c. That is how we use substitution method. As simple as that. So what you need to know is, you try reducing the function to get a simpler function, and then you apply your substitution method. Thank you for watching this video. Please subscribe to my YouTube channel.